I thought about how a TCP session starts. The quote shot in my head, "Everything that has a beginning has an end." And I thought, where's that from? Oh, it's the Oracle in the Matrix. And then I thought about it some more and I thought, she's not very smart. Of course, everything that has a beginning has an end. You just need some epic music behind it. Everything that has an end had a beginning. So by the time we're done here, we're going to surf the web a little and see how it all started. And we would be remiss to do so without our friend Wireshark in the picture. And before I do, I'm going to do one quick command. ipconfig/flush DNS. That's because I want you to see the whole story of what's about to happen. Because I'm going to surf the internet and capture a simple web page. So let's start our LAN capture. I'll bring my Firefox into the picture and paste the web page in that I want to download. As simple as it gets. Quick, jump back to Wireshark and stop the capture. A mere 394 packets caused that event to take place, and I'm going to scroll back up to the very top and see if I can find where it all started. And we're right there on packet 123, ironically. I've got my computer, which is 192.168.123, talking to the DNS server it's configured for, 192.168.1.1, with the protocol DNS, and it's saying, hey, who is help.websiteos.com? Which, if you look at this website, is the name of the website right there. That is a DNS lookup, and it just so happens that the response immediately comes back and says, oh, I've got your answer right here. As a matter of fact, if I expand this out, I can see the answer is 216.251.32.98, and then right after that begins what I want to talk about, the first packet of a TCP three-way handshake. Matter of fact, let's filter that whole thing down. I see the IP address 216.251, so I'm actually going to come up here and type in a filter. IP.addr equals 216.251.32.98, hit enter, and bam, it filters the conversation down to exactly what I want. By the way, if you haven't figured out how to do that in Wireshark, that's one of the big filters that I use all the time. Once I find out what IP address I'm dealing with and I'm trying to find the communication, I go in and I create a filter IP.addr equals, and then type it right in. What it does is find any source or destination address where that appears, which usually captures the whole conversation and filters out anything else that I don't really care about. At the very top of this conversation, packet 125, you can see is from my computer to the web server, 216.251.32.98, which is the web server hosting this web page. And it says SYN. No, not the sin as though you've done something wrong. It's the SYN as the first three letters of synchronization. One unique thing about TCP is that it has a reliability mechanism built in. That is, if any data is lost between the sender and the receiver, it will detect it and then retransmit it. Well, before it can even get there, it has to start the session between the sender and receiver. It does that through a process known as a three-way handshake. SYN, SYNAC, ACK. Think of it just like meeting somebody new. Hi, I'm John. Hi, I'm Fred. Let's talk. That's kind of how it goes. But in the world of TCP three-way handshake, it's exchanging sequence numbers and acknowledgement numbers so that they can be sure to stay on the same page. Let's look more. Now, looking back at this, it might look like my computer has a stutter. It's like, hi, right? Because it's like, why are there two SYN packets right next to each other? Well, these are some of the efficiencies that have been introduced into TCP to where it can have multiple conversations at the same time. I just thought of this. It's kind of like my wife. When we have our kids around, right? She'll be talking to me. The kids will be like, blah, 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 and she'll then turn to them, and it's almost like she's hearing and processing all those conversations at the same time, where I'm like 1980s version of TCP, where, I'm talking to my wife, and all of a sudden the kid's like, Daddy, I'm like, stop! I'm speaking to her because I can't listen to you, right? Well, so TCP is kind of like a wife here. It's trying to or my wife, I should say, is trying to have multiple conversations at the same time. How do I know that? Look at this. See this little thing right here? Stream index 10, stream index 11. These are two different TCP streams. And that if you look right here, this one, SYNAC, it's back to stream index 10. And this is stream index 10. Okay, that's same conversation. Oh, that's stream index 11. So just so we can kind of zone into it, I'm going to add another filter. I'm going to show you kind of how to build filters as you go. It's really easy once you know. That was the dumbest thing I've ever said. It's really easy once you know how to do it, right? Of course it is. So this is a basic filter where I'm saying IP address equals. That's the same thing as equals, just how Wireshark likes it, double equals. This IP address, right? So we filtered it down to that. And then I'm going to put but of course, everything is double in Wireshark. It already filled it in there. TCP stream equals 11. I'll hit the enter key. And now you can see, my computer doesn't have a stutter because it's ignoring that TCP stream number 10. Now, if you look right here, all of these guys are 11, 11, 11. And in this video, all I want to do is talk about how the conversation gets set up. Now look at this. Watch it. Seriously, if there's a child talking to you right now, be that single TCP. Don't talk to me. This is going to be really important, okay? So right here we have SYN. This is it going, hi, I'd like to communicate with you, but there's more. Inside of that SYN is a sequence number. See right here, it says sequence number 0. And Wireshark, by the way, just takes the time to mention, this is a relative sequence number. Truth be told, the sequence number is probably like 4,693,000,000, some giant number, because these are the sequences of data that my computer's sending out. The reason it's saying it's relative, but it's 0, is because for this TCP stream, it's 0. This is where it all starts. And notice right here, if you look what happens right after that, it says SYN 0, right? The other side responds. So look at the source. This is me, my computer. Hi, web server 216.251. This is me. Hi, SYN. I have sequence 0. The web server comes back and is, this is a web server. He's like, okay, hi, SYN, right? I'm the web server, and I got your sequence 0. What do you mean, Jeremy? I mean, look right here. This is where it's really important. Sequence 0, ACK 1. What does that mean? It means I got your 0, and I'm now expecting your next sequence to be 1. Roughly speaking, it's not exactly this way, but I want you to follow. I just sent packet number 0. The computer receives it and sends a message back saying, got that. Next one that you're going to send me is 1. What that tells my computer when it receives it is, oh, he got 0. Okay, so I'm going to send him 1 now. Now, imagine every one is just 1 digit. When he gets the next one, he got 1. What's his acknowledgement going to say? What's it going to ask for? 2, right? Did you get that? 2. ACK 2. Okay, he got my 1. Here's 3. Keeps going like that. But here's where I'm gonna do a +1. +1. It's kind of. This is tough. This is hang on. It's not packet numbers. It's data bytes. So instead of being here's 1, 2, here's 2, 3, it's going to be here's 10,000, 10,001. Here's 52,693, 52,694, right? Right? Did you get that? So the ACK will always be a +1 to whatever amount of data that I'm able to send at once. No, hang on. What governs how much data I can send at once? How big my TCP window is. Big concept. Big. I'm dumping so much on you right now. TCP window is how much size, how much data can I send at once before I expect an acknowledgement back. TCP is designed to get faster the more reliable it detects the network being. So much I want to tell you right now. I'm just trying to. But so here's what I mean. Have you ever done this? Have you ever been in Windows and you drop a big file, like you're copying a file, or Mac? Mac does the same thing. You copy a big file, and it comes up. It's like time estimate 1 day, 5 hours. You're like, what? And it's like, no, never mind. 2 hours. You're like, 2 hours. It's like, no, 5 minutes. What? Like, is Mac crazy? Is Windows crazy? Why has it got this crazy time estimate? Is because the way TCP windowing works is it will send a small amount of data, get an acknowledgement back. Windows looks at that and goes, okay, well, That's great, but if we're just sending a small amount of data and acknowledge, small amount of data, it's going to take like a day and a half. And that's where we're like, you're crazy, Windows. Well, behind the scenes, by the time we get the words you're crazy out of our mouths, it's already like, let me try sending a little bit more. Okay, here's a big chunk of data. Got it all? Okay, got it back. And then that's when you start seeing the time shrink down, is when you can send a whole bunch of data and just get one acknowledgement back. Oh man, there was so much goodness right there. I just want you to like rewind that like 5 times and just listen to it again. Okay, so now let me pick up from here. Notice right here, it's saying, okay, send sequence 0. Notice this little gem it's got right here. It's saying, my default window size, meaning my computer, 192.168.123, my window size is 64,240. Oh, wait. Does that make sense? My normal TCP window size is that much data. The web server responds, and it's like, well, my window size is 4,380. Matter of fact, down here, you can see that little embedded chunk right in the packet. Truth be told, as you see this go down, you notice these window size start jumping all over the place. This is known as a TCP sliding window, meaning the computer and the server are adjusting and increasing and decreasing that window size based on how much buffer space they have to hold that data. In a way, it's telling the other side how much data it's allowed to send before you go, okay, wait, let me process that. I'll give you acknowledgement, and then you can send me some more. It's very human-like, right? If you're married, you know what I'm talking about. You'll be talking. You're like, okay, hang on, give me a sec. Okay, so what you're saying is that, right? So same kind of thing. The computers are like, I only got so much memory, so tell me, okay, I got it. Let me process that. Okay, send me some more. Okay, so let me bring this back. I'm going to put these puzzle pieces together because this is supposed to be just key concept 1 and 2, and I'm kind of tiptoeing into some of the other concepts I want to talk about in other videos. So let me just assemble this for now. Every time our computers want to speak to each other, either two computers talking or a computer to a server it doesn't matter. If they're using TCP to communicate, it will always start with a 3-way handshake. SYN, SYN-ACK, ACK. The one who sends the SYN is the one who's trying to start the conversation. So this computer initiated the communication, and in that SYN, he says, here's my starting sequence number for the data I'm going to send. In our case, the relative sequence number was 0. The server gets it, acknowledges that 0 by saying, I got your 0, so I'll include acknowledgement number 1. And by the way, this is where I'm going to add a little bit to it, my starting sequence number will be, let's just say, 0 as well. Because remember, this is two-way conversation. And the last little bit is the initiator responds back and says, I got your 0. Oh, and how do you think he says that? By sending acknowledgement number 1 this direction as well. Bidirectional, two-way conversation. Each side having their own sequence number, each side having their own acknowledgement number. And it's this sequence number and acknowledgement number that keeps them on track the entire time. Once they've got that starting point, so these guys started from 0 and then they quickly moved to a 1. We just happened to name them. It's Bob and Lois. The next message that's probably going to be sent by Bob will be an HTTP GET message because we're trying to access a website. Get blah. And it's actually not a URL, it's a HTTP command. And maybe that request is, let's just say, 20 bytes of data. That means that his sequence number will increase to 21. The original sequence number we were at plus 20. Shoots over here. This guy, to confirm he got that request, will send back acknowledgement number what? Come on, think about it. Pause the video if you have to. Acknowledgement number 22, right? Because that says, I got your 21. Next one I'm expecting is 22. And he might send a little data of his own with this. He might send the first 1,000 bytes of that web page if we were downloading it. Which, by the way, would put him at sequence number 1001. That's 1000 plus his starting sequence number. And when this guy gets it, he's going to send back acknowledgement number what? Come on, you're getting it, right? 1002. Saying, I got your 1001. Start with 1000 2, and the server will probably be happy to oblige. Oh man, I'm so glad that's captured on video. That's probably the best, I feel like, gut level I've ever taught TCP windowing and sequence number. It was a lot. It was a lot. So if you didn't get it all, that's okay. I just want you to get in this video the SYN, SYN-ACK, ACK, the three-way handshake that starts every single one of them, and that relative understanding of what sequence numbers and acknowledgement numbers will do to keep our conversation in sync. In the upcoming videos, I'm going to kind of unpack a little bit more the windowing and how this communication goes, finally with the wrap-up, the end of that conversation. For now, every TCP session that has an end had a beginning. And you got to see how it all started. I hope this has been informative for you, and I'd like to thank you for viewing.